What were we doing last time? Rational functions, very good. And I asked you to go plot those points, didn't I? Did you all do that? You did. Okay, so does anyone have it written down? All right, thank you. I'm going to copy this real quick on the board just to remind us of where we were. We had the x and y axes. We had a vertical asymptote at 3. We had another one at -3. We had an x-intercept at 0 and at 6. And we had a horizontal asymptote at 1. And then we had picked these test points. We were going to plug in f of -6, f of -1, f of 2, f of 5, and f of 8. And that's what I asked you to go home and do, right? Thank you. And it was x squared minus 6. Our original function was f of x equals x squared minus 6x over x squared minus 9. Okay, so that's where we were, right? And I asked you to go and plug these points in and get some values. So what were the values that you got? Whoever could volunteer them for me. At negatives. For this you got 2.67. Anybody else get that? Okay, close enough. 2.6 we'll say. -1? -0.88. Anyone else get that? .75? Yeah. Okay, well let's keep going. You both got negative numbers, right? Okay, how about at 2? 1.6? 1.6? Anybody else? Are these the only two that plugged in numbers? Oh, that's why I'm asking. How about for 5? Should I have a quiz right now? Who had the problem? Who did this? I sent you home to plug in 1, 2, 3, 4, 5. You mean to tell me that only 2 people plugged in 5 numbers into a function for homework last night? Raise your hand. Who plugged in 5 numbers for homework? Okay. Who didn't? Why not?
I forgot.
You forgot? Okay. All right, do y'all know what we're doing here? We're taking this number, plugging in for x, and computing it? Okay. 1.6 for this one? For 5? -0.31. Okay. And then for 8?
I got negative not negative, but they're out 0.29.
0.29? Yep, 0.29. Okay. Are there any questions on what you have to do to get those numbers in here? Do you need me to do any of those, or you're happy? You're happy? Okay. So with these points, what? You did it wrong? You know what you did wrong, though? Okay. So once we have these red numbers over here, we need to come back over to our graph, and we need to plot these points. So I'm going to go to plot this first. And remember that this represents a point on my graph, -6, 2.6, right? It's the x-coordinate and the y-coordinate. So I'm going to go to -6, which is about, I don't know, somewhere around here. And I'm going to go up how much? 2.6, 1, 2.6, somewhere around here. That good? And I think I'll make all my dots red. These are all points on my graph. Okay, and then at -1, I'm at -0.88. So at -1, I'm down, right? Down a little bit, okay, here. And then at 2, I'm at 1.6 something. So at 2, that's 1, 2, I go up 1.6, somewhere around there. We good? And then at 5, I'm at -0.3. So here's 4, here's 5. Negative 0.3 just means down a little bit. So I'll put a point here. And then at 8, I'm at 0.29. So here's 7, here's 8, and I'm at 0.29. That's going to be below this dotted line, isn't it? Because that, how high up was that dotted line? 1. And so I'm right, I don't know, somewhere around here. All right. Got it? Somehow that's all we need. Now we can graph it. If you remember from the end of last class, before we did this, we had plotted all the information, and I tried to draw it, but there was different ways I could draw it, and they were all different. With these points, there should now only be one way to draw it. All right, so let's try and draw it. The way that I suggest you do this is by starting at the furthest point to the left, and we're just going to move our way from left to right, across like a book, like we would read a book. So we start with this leftmost point. Imagine that you have to draw from this point to the left. You have to draw it this way, so we can figure out, what's the function doing over here, and we have to draw it to the right. Understand? So as I draw it to the left, can anyone tell me what has to happen? And why? Can't touch this. Okay, that's semi-correct. A little bit more. And it has to go toward it. Now, remember we were talking about long enough timeline, the survival rate for everything drops to 0, and that dotted line was where you were headed towards? This dotted line is where we're headed towards. So as I move out to the left, I know that this must drop down towards that. And maybe I should extend my dotted line out further. And that's all I need to draw. So the idea is that this will continue to go closer and closer to that without actually getting there. All right, now from this point, I need to draw it to the right also. So what's going to happen is if I were to start drawing, I'm not going to do it, but if I start drawing this to the right, what would happen eventually here? I would run into this vertical dotted line. And do you remember me saying, like, what if I tried to run into the wall, right? I hit the wall and eventually I'd have to do what? Go up, right? Now we could also go down. Think about this. If this wall's in my way, and the only way to avoid it is to go up or to go down. Do you agree? Why can I not go down? If I go, watch what happens if I go down. If I go down, I'm going to go like this, right? What did I just do right there? I crossed the x-axis. And that means that's an x-intercept, doesn't it? But the only x-intercepts we have are where? 0 and 6. So by going down, you actually created an x-intercept that does not exist, so this is no longer correct. Understand that? This is like a process of elimination. You have to think through this. So instead, I need to go towards this and turn up. With me? Okay. So I'm going to go up instead, and I'm not going to do this. I'm not going to go like that, because doesn't this kind of look weird that it just goes like this and then kind of turns sharply? All these rational functions are smooth. So when I draw it, I'm going to just continue from that point and continue this curve nice and smooth. Oh, yeah, that'll work. And then turn it up like this. And there's my vertical asymptote. I don't like that, but that'll work. You got it? Okay, now once you get to that vertical asymptote, you actually do have to pick up your pencil and you have to move to the next point that you have to the left. The far left point that's on your graph, which is this one. And you have to do the same process. Draw it to the left, draw it to the right. So let's start going to the left. What happens? I have a barrier, right? Another barrier. So I'm either going to turn up or I'm going to turn down. Right? Which one is it? Down. Why not up? I would cross the x-axis and create an x-intercept. So I can't do that. So I'm going to have to go down from here, right? So it's supposed to go down. And I'm going to kind of store that in my memory here. I'm going to go down here. What about if I draw it to the right? Well, I've got to get up to that point, right? So I'm going to have to connect these two together. And then if I try and draw from this point to the right, what happens? have to connect that one, right? So like between here, here, and here, isn't this like first grade? Connect the dots? See, I'm just going to connect these together like this. But as I go this way, I have to dive down. So I'm going to just kind of go like that. Make sense? And then to the right, as I'm at this point, what happens? Barrier is going to have to go up. So I'm going to turn up like that. It's kind of a weird looking function, huh? Once I draw that up, it goes up forever, right? I have to pick my pencil up, go to the next left point, which is here, and then go out to the left. What happens? It's going to have to turn down. And then between here, here, and here, first grade, right? Connect the dots. And then from this point to the right, what has to happen? How do you mean? I've got to go up towards that dotted line. Get closer and closer to it without touching it. So it's going to go something like this. It's going to go up here. I'm going to put a little arrow there like that. First grade, connect the dots. Up, there's a barrier. I have to go down. And this is the graph of this function. What do y'all think?
Complicated.
It's a lot involved here, right? Okay, this was our first example. Let's do another one. I plan on doing maybe 2 examples, and then I was going to hopefully put you up, like maybe we'll do some group problems, either up on the boards or at your desks. And then I'll send you home with a couple of problems to do. Okay? All right, the next one I want to do is f of x equals, let's go 5 minus x over x squared minus 9x. All right, is this a rational function? Yes. What makes this a rational function? It's a polynomial divided by a polynomial, right? What is 5 minus x on top? Couldn't I rewrite that as x, negative x plus 5? That by itself, if I asked you to graph that, what would it be? A line. Okay? The bottom by itself, if I ignore the top, the bottom by itself would be a parabola, wouldn't it? So if I have a line is a polynomial, a parabola is a polynomial. If you divide 2 polynomials, you have a rational function. All right, do you remember the first step? Yes, set the top to 0, but what was that? Why did we do that? What does that give us? The x-intercepts, right? To find the x-intercepts, I set the numerator equal to 0. That should be pretty straightforward, because that's a linear equation. I trust that you could all solve for x. How would you solve for x? Would you move the 5 over, or would you move the x over? Yeah, I would move the x also. You could do it the other way, but I would move the x over, so I'd add x to both sides. And then I'd just get x is 5. What is this on my picture? An x-intercept. So that's a point, right? That's going to be a point. I'll remind you again, this is a point on the x-axis. All right. What's the second step? Set the denominator equal to 0. What are we doing when we are doing this? What is it that we're going to find when we do this? The vertical asymptotes. I abbreviated those with a VA last class, didn't I? So we set the bottom equal to 0. And that's a quadratic equation that we need to solve. Does anyone have an idea of what you would do to solve that one? Take the x out. Let's factor out an x. It has a GCF, doesn't it? The left side has a GCF of x. X minus 9. Right? That's what you would get. And now you can set each of those factors equal to 0. So I set x to 0. I set x minus 9 to 0. And I solved those two little equations there. First answer, x equals 0. There is really nothing to do there. X is 0, and that's it. The other one, move the 9 over, so you get x is 9, right? Add 9 to both sides. All right, what are these going to be on my graph? Not points. They are our vertical asymptotes. What are those when I draw them? Dotted vertical lines, right? Those create those vertical walls. Okay, so these are my vertical dotted lines. Okay, good. Moving right along. Third step. Horizontal asymptotes. All right, these are going to be those things at the end, those dotted lines at the end where our graph goes towards them, right? And when we go to find these, there were 3 different cases that we could have. Do you remember what we look at? What do we look at when we're talking about horizontal asymptotes? The degrees of the numerator and denominator. So what is the degree of the numerator? 1. I'm going to write that down here. The degree of the I said top last class, didn't I? The degree of the top was 1. What's the degree of the bottom? Was 2, right? That's this 2. We're supposed to compare these two numbers. Here, the top, right, is smaller than the bottom. What case was that? I gave you 3 cases, case A, B, and C last class. Was it B? This is case B. So if you look at your notes, case B, if you have case B, then what's your horizontal asymptote? Which means that the x-axis is your horizontal asymptote. Look, this horizontal asymptote, I want to make sure you understand something about it that's important. Do you remember with the polynomials, that table that I drew over here, where it showed like up, up, down, 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 up? Like, remember that? Okay, that told us about what we called end behavior. End behavior. The horizontal asymptotes, the horizontal asymptote is the same thing. It tells you about the end behavior of this rational function. Except that it could, you know, instead of going up, up, down, down, or something like that, it's flattening out, right? Unless we get case C. In case C, it doesn't flatten out. But that's the next example I'm going to do. All right, what's next? Step 4. Put all this information, right? Take all this information that we just got and put it onto a graph. So here we go. Draw my x and y axes. Give myself plenty of room. And starting out with the first piece of information that I have an x-intercept at 5, right? That is a point that goes on my x-axis. So I walk out 5 units. And I'm also keeping in mind here that I have vertical asymptote at 0 and 9. So I'm going to need to be able to go out as far as 9 on this. What I'm saying is don't make this 5, because then you're going to have to draw more, right? So I'm going to put 5 about right here. Put a dot, right? The next thing is x is 0 and x is 9. And I'm not going to put dots at 0 and 9, right? I'm going to put vertical dotted lines. So let me do the one at 9 first, because that's easier. I put a little dash here, 9, and then I'm going to just continue with dashes all the way up. There's my barrier. I also need another vertical barrier at 0. So I've had students in the past ask me, like, well, how am I going to put a dashed line on top of a solid line, right? So this is what my students have done in the past. I kind of like it. They just do kind of like diagonal little dashes instead. It works, right? You can still see it. Okay, there's my barrier. Next piece of information. I have a horizontal asymptote, but it's the x-axis. Now the x-axis, of course, is this, right? And I need to draw a dotted line at the edges. I'm going to have enough, I can erase a few here. Just make sure you're aware that it's an extension of the x-axis out the left side, and I need the same thing over here. So I'm going to have to move that x. Okay? Do y'all see that? Do not draw a dotted line all the way through. The horizontal asymptote only tells you about the ends. It has nothing to do with what's happening in here. Okay? Yes or no? Yes?
Yes, sir.
Okay. To illustrate that, on the last problem, didn't our function do this? Like that, and here we had our dotted line here and our dotted line here. Wasn't that what it was? If you had drawn that dotted line all the way through, you would probably scratch your head right here and go, what's going on there? I crossed through the dotted line, right? That's what you would do. But that's because you shouldn't have drawn the dotted line all the way across. The dotted line only tells you about the ends. Get it? If you draw it all the way through, you're going to have problems because you're going to confuse yourself later. And if you go to a tutor and the tutor draws it all the way across, just smack them on the hand, tell them not to do that, okay? A lot of the tutors do that. They draw the dotted line all the way and it drives me crazy. All right, so only at the edges, right? All right, that's it. From here, is this enough information to graph it? No, we still need test points, right? And how do we find the test points?
Use the horizontal and the vertical.
We look at the, not the horizontal, only the verticals. Sorry, verticals and the x-intercepts. You count them. How many do you have? 1, 2, 3. So how many test points will we have? 4. One more than the total. So I should have 4 test points. Where will they be? Where do they have to be? I have to have one on each side of each vertical and each x-intercept. So I want to see if you understand this. Can somebody give me a test point? I'll tell you whether or not it's good or not.
Sorry, 10.
I heard -5. Is that what I heard? Is that what I heard?
Yeah.
-2. Okay, I'll go with -2. -2 is going to be about right here. Everyone, I'm going to take that and just circle it. Notice I put a little X here. I'm not putting a dot. Do not put a dot. If you put a dot, you're going to think it's an x-intercept, then you're going to screw your graph up, right? -2, I'm going to test that. Does everyone agree that's a good test point? Yes? Because that gives me a test point to the left of this vertical. So there's nothing else over here, right? No other verticals, no other x-intercepts. So I've got something to the left of this. Give me another one. 2? 10? 10 would be out here. Everyone okay with 10? That would take care of something on this side, all right? Someone give me another one. 1. 1 would be in here, and that would give me something to the right of this vertical, and that's also to the left of this x-intercept. So that's good. So that's 3. I should only need one more. 7. 6. 8. Any of those would work, right? 7. So we just check again. Do we have a test point between everything, right? Between these two, do we have something? Yes. Between these two, do we have something? Yes. Do we have something on the outsides? Yes, yes, we're good to go. And those numbers get plugged into the original function. And maybe we'll need our calculators for this part. I'm going to say what's f of -2? What's f of 1? What's f of 7? And what's f of 10? All right. What happens if you plug in -2? 5 take away -2 is the same as adding 2. So I get 7 over. What's -2 squared? 4. And then what's -9 times -2?
18.
Plus 18. So this should be 7 over 22, which is approximately 0.32? 0.32? Approximately 0.32. Y'all good? Understand? I don't want you to come all this way and do all this perfectly and then you can't plug numbers into a function. Make sure you can get this. All right, how about 1? We get on top, 5 minus 1 is 4. 1 squared, 1. Minus 9 times 1, 9 times 1 is 9, so minus 9 here. This is 4 over what? Negative 8, which is exactly negative 0.5. Negative 1/2. What's wrong?
I'm just figuring out, like how, because I don't really know how to, like, do you just plug in the 1 with the x?
Yes, I'm just replacing this x with 1, this x with 1, this x with 1.
Okay.
That's all I'm doing.
Okay, that's what I was confused.
Yeah.
When I was doing the homework, I thought you would use those to do it on the graph.
Which ones?
For like when you're doing the f minus 2, I was thinking you'd use those on the graph.
We are going to use these on the graph. We're going to put these on the graph. We're going to plot these as points. I'm just getting all of them first. So I'm about to get 4 points.
Yeah, we're looking for the y, basically.
Yeah, we're getting the x. This is the x value, right? This is the y value. This is what goes into the function. This is what the function spits out. So the x coordinate, y coordinate, x coordinate, y coordinate. And we'll plot those as points. How about 7? 5 take away 7, negative 2, over 7 squared, 49, minus, what's 9 times 7? 63? And that's negative 2 over negative 14, which is 1/7, positive 1/7, which is approximately 0.1, point what? Really, is it? Okay, 0.14. And finally, 10. You plug 10 in, you get 5 minus 10 on top, which is negative 5, over 10 squared, 100, minus 9 times 10, which is 90. So you get negative 5 over 10, which is negative 0.5. Y'all all right with that? Okay, so now I'm going to plot those points, but I'm going to just remind you that these are points. The first point that I have is the point negative 2.32. The next point I have is the point 1, negative 0.5. The next point I have is 7.14. And then the last one I have is 10 and then negative 0.5. X coordinate, Y coordinate, X coordinate, Y coordinate. I'm going to plot these. Yes?
Is it okay if you don't put the test points on the graph?
If we don't what?
Like mark the test points on the graph?
Why wouldn't you?
Like the X's.
Oh, like don't put them here, like don't mark them? Oh, that's okay if you don't. Yeah, that's okay. Yeah, you don't have to, you don't need to put these little X's in these little circles. But when you plot these points, please make sure that I know, like somewhere on the page, like let me see your test points. Like let me see what they were. So negative 2, I'm going to go to negative 2, and then from there what? Up 0.3. So what's 0.3? I don't know. Like 0.3, it's up a little bit. Okay, great. That'll work? Is that okay? I'll do that. I'll do this in black. All right. So there's one test point. Then at 1, here's 1. I need to go down 0.5. So somewhere around here. Again, I'm just kind of, guesstimating this. And then at 7, I'm at what? 0.14, so that's like right here. Again, guesstimating. And then at 10, I'm at negative 0.5, which puts me kind of, this is in the way, kind of, so there. Right? And that's it. According to what I've said, this is all the information we need. We should be able to graph this now. So I start at the leftmost point, and we're going to go around and we're going to do tables. Let's do tables. We haven't done that in forever. So this table, table A, what am I going to do as I draw from this point to the left? Okay, so just to the left though. Where do you want me to go? Tell me where I should go. Should I go like up here? Should I go down here? Should I go straight? Down towards the dotted line. Perfect. That's what I want to hear. You want me to go down towards the dotted line like this. Good enough, everyone? Okay, we'll continue. Still this table, but you're out. You're out. So to the right, what? Either one of you. Up. Good. Both of you simultaneously. Up like this, right? And why couldn't I go down? I'd create an X-Intercept, so I can't do it. Very good. Okay. Table B. This point. Down this way? You mean towards this dotted line? Okay, I'm going to do that in a second. And then what am I going to do as I draw to the right? Connect these dots together, right? So I want to make this kind of look nice. I don't want like jagged corners and stuff like that. I want to make sure that it looks nice and smooth. So when I do this, I'm going to do this kind of all in one motion like this. All right? And when I go through these points, what's going to happen? You all right? Yeah. Okay, when I go through these points, what's going to happen when I get to this point? Going to go up. So can you see the whole thing together here? How that's going to look? Whoa, like that. Oh, got it. Okay, good. This looks very similar to the last one, doesn't it? All right, last table, we'll go in the back there. This is my last point, right? So to the left, what?
Down.
Down, because of the vertical barrier, right? So it's going to go down. And then to the right?
Up towards the X-axis.
Towards this, but don't go past it, right? So flatten out like this and go down like that. Voila. That's it. All right. One more. And then I think it's time for you to do some. How about f of x equals x squared minus 3x minus 18 over x minus 3. Is this a rational function? Yes, it is. First step, X-intercepts. To do this, I set my numerator equal to 0. The numerator is a quadratic, isn't it? And so to solve that quadratic, I have options. One option is factoring. The other option is the quadratic formula, right? So can that factor? I think it does, all right? X minus 6, x plus 3 should work. Now, please understand, you may not be able to get that as quick as I just did, but I do expect that everybody here could solve that equation and get 2 answers. How you do that is really up to you. Understand? Like you could do quadratic formula, but you should be able to get to the 2 answers, which are what? X equals 6 and x is equal to negative 3. All right, so you could get that 2 ways. You could set each one of these equal to 0 and get these 2 answers, or you could use a quadratic formula and get these 2 answers. These are points on my graph, right, on the x-axis. Second step, vertical asymptotes. To do that, I set the denominator equal to 0, and I just get one answer, 3. And isn't that nice? The third step is to look at the degree of the top and the bottom. So what's the degree? I'm getting the horizontals, sorry, horizontal asymptote. The degree of the top here is 2. The degree of the bottom is 1. And that means the top is bigger than the bottom, right? And what case is this from your notes last class? Is it case A? You sure? Okay. And what did I say happens during case A? There's no horizontal asymptote. No horizontal asymptote. Yeah, so I also in your notes wrote something else when this happens. When you have no horizontal asymptote, that means that you're not going to flatten out on the edges. Like, see how we flattened out here on the edges? That's not going to happen. That means that on the left side, it's either going to go up forever or down forever. So it's going to do this or this. I actually don't know which one yet. So it's going to go up or down. We'll have to figure it out. Our test points are going to help us figure out which one of these it is. And then on the right side, same thing. It's going to go up or it's going to go down. I don't know. Or. This is an or. Okay, OR. It's going to go up or down on the left and right. And now I proceed. Fourth step, picture time. Put my information here. So start with the first thing we got, 6 and negative 3. I'm going to put those, what are those going to be? X-intercepts, 6 and negative 3. So when I put them on here, they're going to be,
6, 0, and -3, 0.
yes,
On the x-axis.
on the x-axis. Just put a dot, right? That's what you want. All right, so dot at 6. Let's say that's 6. And let's say negative 3 is about here. 2 x-intercepts. Vertical asymptote is next. That's at 3, right? So I go to 3, and I put a dot. No, don't put a dot, right? No. Put a dotted line. That's okay. But not a dot. And that's all. Because there is no horizontal asymptote, right? I've put all my information down.
You still need the
Test points, right? That's what we need now. How many test points should I have? 4, right? Count these, 1, 2, and then add that 3. So I have 3 total x-intercepts and verticals together. I have 3, so 1 more than that. All right, let's get test points. We're gonna move around tables again. Could you give me, yes, yes. Could you give me a test point? -2. Okay, -2 would be somewhere about here. Okay. Everyone agree that that would be okay? Yes? Good. Give me something else.
-4. Or does it has to be outside, right?
Yes, you need one outside, so -4. Okay, you're out. 7, good. 7 will give us 1. Everyone still good with that? That's 3 of them. We need 1 more. Where do you still not have? I've heard 2, I've heard 5, I've heard 4. 4? 4? 4, 5? Okay, why not 2? Do I have something between this x-intercept and this vertical? Do I have something there? Yes, I already have something, don't I? Don't let this line confuse you. That line really is just my y-axis. If you don't have it here, do you see that you already have something between these two? So you don't need that. And actually, you might confuse yourself. If you accidentally put that in there, if you did 2, then you would think you have all 4 and you're good, but you're not. You don't have anything between these 2 yet. So 4 or 5 would work. I'll put 4. Okay? And those all get plugged into the original function. Plug in time, plug in time. I mean, if you're honest with yourself, this is actually pretty fun, right? No? Okay. I tried. If fun is defined to be drawing rational functions, then this is fun, right? All right, f of -4, I need to figure out. F of -2, I need to figure out. F of 4, I need to figure out. And f of 7. Let's see if we can do this. Plugging in -4 for x. -4 squared. 16. What's -3 times -4? 12 plus 12 and then minus 18. All over. -4 minus 3 is -7. So what's 16 plus 12? 28. Take away 18. 10. 10 over -7, which is approximately -1.42. Okay, good. Same thing for -2. -2 squared. 4. Okay, -3 times -2. Positive 6, and then minus 18 over, careful here, -2 take away 3, -5. Equals, let's see, top is 10 take away 18, -8 over -5. Negative divided by negative is positive, so this is going to be 1.6 exactly. And you continue. Here we're going to get 16 take away 12 take away 18 over, oh that's nice, 4 minus 3 is 1. So what's that? -14. -14. And finally, 7. Let's see, 49 minus 21 minus 18 over 7 minus 3 is 4. So 39, is that 10 on top? 10 on top over 4. 10 fourths is the same as 5 halves, which is 2.5. There we go. I get to draw this now. I'm really excited about this. At -4, I'm going to place a dot down, right? 1.42, approximately. So I don't know, somewhere around here. At -2, I'm going to place a dot at 1.6, which will be somewhere around here. At 4, I'm way off at -14, right? So it might go off my graph. I'm just going to put it down here. And then at 7, we're at 2.5. So somewhere around there. Now look, these pictures that you draw are not going to be like perfect pictures. Kind of like, do you remember with our roller coaster polynomials? They weren't perfect. I know y'all are busy paying attention to what I'm doing over there, but do you remember with our polynomials? We might have something like this where it would cross through and then bounce and then it would cross, but someone else could come in here and draw it. and it would go like this, and then bounce like that, and then go like that, and those would both be correct answers. Same thing here. We're going to have different variations in how our pictures look, but they'll all have the same X-intercepts. They'll all like behave the same way, and that's what we're looking for here. If you want to get into the detail of how to get all the, like to get this very, very precise picture, then I think I told you for this you'd have to take calculus, right? Yes? I actually did a problem like that in calculus yesterday. We graphed a polynomial function. We found all these like highest points and stuff and lowest points, and it takes about 45 minutes to do one problem. It's a long process. Okay, here we go. Ready? Where did we leave off? We left off, we're right here. Ready? Where am I going? So I've got to go down here, right? There's nothing to flatten out to. Remember we said it had to go up or down? Why not up? You would create an X-intercept if you went up. Do you see that? If you turn this thing up, then somewhere you've got to cross through here, and you're not allowed to. You're only allowed to cross here and here. So this is really like a process of elimination. It has to be down. So it's going to go down, and then how about between here and to the next point? Connect, and then to the next point? Connect. Okay, so that should be pretty smooth. I'm going to go down like this, connect, and then how about from this point? I'm trying to come this way, right? The barrier is going to be in my way. So if I try to go this way, barrier's in my way, where am I going to go? Got to go up, right? So I know as I come this way, it goes up. So I'm just going to kind of continue it again, nice and smooth, like this. See it? Yes?
For the end, is it straight or is it curved?
It's curved. It's curved. Yeah, it's not a straight line. You could do that. You could put a little bend to it like that. It doesn't really matter how you do that. Any of those would be okay. Right? It's just the idea is that it's not flattening and it's not going that way. It's headed down that way. Okay?
So that's okay. Wouldn't it be creating another one?
Where? Here?
Yeah.
That's a y-intercept. That's different than an x-intercept. We never found the y-intercept, right? We never did. But if we actually did, we would actually know that number.
Pros, do we not need the Y?
Pardon?
Do we not need the Y?
You don't need the y-intercept. No. All right, now I jump to the next point, which is right here. So we're at the last table here. Where am I going to go from this point? Down. So to the left, I'm going to go down. And then, what is it from here? I've got to get to here and then to here. So let me connect these. And then once I get to this one, where am I headed? I've got to continue to go up, right? Because this is the end behavior. It's either up or it's down. It can't come back down because I'd have an x-intercept. So this is it right here. There's your picture. All right, what time is it? We've got about, let's do an in-class group activity quiz. How about that? I'm going to give all of you the same problem. You can work on it together in groups. I want everyone to turn in their own copy of the problem. And you have approximately 20 or so minutes to do this one. I want you to sketch. Put your name on it and put today's date, which is the 2nd, 3rd of November. Can you believe it? Sketch f of x equals, and I want to make this work perfectly, so give me a second here. And then we have, let's see. So here we go. 2x squared plus 4x over x squared plus 3x minus 10. Good? There you go. Enjoy. If you have any questions, like as you're moving through, or how about this, once you get parts 1, 2, and 3, raise your hand, that way I can come by and check, because you don't want to start sketching something based off of information that's incorrect. But I'll be right back. I'm going to go get some water. We've got a little group quiz going on in there, okay? Sorry. Good. You have all the information? Yes, 2 over 1, those 2. So it'll be up 2. Nope, it's just that fraction. Was there a question? Did someone ask a question? No? Okay. Okay, so you have the correct information. Wait, was it 2 or negative 2 on top? Negative 2? Careful, that should be... oh, you wrote it down wrong. See, it's a plus? No, you wrote it, this is right, this is wrong. You wrote 2x squared, it should be plus 4x. Right here? Yeah, so that's going to change your sign in the middle right there, which is going to change that to a negative, which of course is going to throw... It's just going to change where your x-intercept is down there. Everything else is right. You working on the factoring part? Okay.
So the number 5?
You all good?
Okay.
0, negative 2. What's your horizontal?
It's 2.
2. Okay. No, I didn't see it on there. Got 2? Okay. X-intercepts. 0. 0, negative 2, and then verticals 2. I think that's right. That looks good. Come back over here for a second. What did you have for your verticals? I don't remember looking at them. Negative 5, 2. Okay. Negative 5, 2. Yep. Vertical, horizontal is, look at that again. What's the degree of the top?
2.
Degree of the bottom?
2.
Okay, so you create a fraction. This is the case where you create a fraction, but not of the degrees over each other, the leading coefficients. So what's the leading coefficient of the top? 2, the number in front, right? What's the leading coefficient of the bottom? What's the number in front of x squared? 1.